Okay, here I'm going to describe some of the basics of paper chromatography, which you might be familiar with, producing pretty colors on paper based on using ink dyes as just a model example. To start off with, how does chromatography in general work? What are the basic components of how this works? Well, it works through what's called capillary action, and that's the movement of a liquid within the spaces of porous material due to the forces of adhesion, cohesion, and surface tension. Here we see blue liquid, and we see the different diameters of these glass tubes. As that diameter gets smaller, we're noticing that liquid is able to travel higher, and that's through capillary action. The liquid is able to move up in the filter paper because of the attraction to itself is stronger than the force of gravity. As those walls get closer, those forces of attraction is greater, and they can travel further up this glass tube as an example. In paper, the pores are very small as well, and that allows it to, again, move and fight the force of gravity. So the solubility, which is the degree in which a material or solute dissolves in a solvent. Solutes dissolve into solvents that have similar properties. What's called like dissolves like. And what that means is that if a substance is polar or has a charge to it, for example, water is polar and has a charge to it. So a substance like that will be able to dissolve very well in water. If something is non-polar, you might want to use like an alcohol base because that also doesn't have a charge to it. So when it says like dissolves like, that's kind of getting into the components of the properties of the solute and the solvent, looking at polarity or charge being one key example. This allows different solutes to be separated by different combinations of solvents. So what to look for is while you may see one color initially, this is looking particularly at inks, there may be separated into two or more individual colors. So this will happen over time with certain color spots traveling to the same distance within your paper chromatography. In some examples, the concentration of the alcohol in the solvents is changing, resulting in different traveling distances of the dyes. And you're going to see an example of how that plays into the distance that certain colors will travel. So first off, go over the basic kind of setup here of paper chromatography. You have the starting line. This is where the inks are initially placed. You can see that dots here, it go through the center of that initial ink. You'll notice that the liquid level is below those inks. You don't want that liquid level initially to come in contact with the dye because it will dilute it into this mobile phase. What's going to happen is this mobile phase is going to wick its way through this chromatography paper. It's going to move its way up against the force of gravity. As it does so, it's going to pick up these dyes and separate them out based on their individual colors. We then have the finish line, which is the highest point that the solvent travels, and we have that stationary phase in this case, which is the chromatography paper, and in this example, it's all encased in a beaker to keep everything contained. So chromatography over time, this doesn't happen immediately. Initially, you can have a really quick start. We can see how it very quickly will progress. And in this example for this paper, for this isopropyl, for this material, it takes about 30 minutes to run to the top. But you can see at 25, you have a pretty good indication. 30 would be the run time. Sometimes you don't want to run it too long or too little because you want an adequate separation without it, quote, overrunning, or you don't want everything to be compressed either. So when observing our chromatography here, as I mentioned, the concentration can play a role. And in this case, this just shows you an example of how it does play a role. Here's our different percentages. This is looking at alcohol-based solvent. And we can see at 0% alcohol, the dots barely move at all. And as we increase the percentage, we're noticing an increased distance of travel. So this is important to take into consideration the properties of the paper or the coating on the paper, the solute, the solvent, and what you're looking at separating. In this case, 100% looks like it does produce quite a good separation, though we do kind of lose some of that yellow color, at least in this example, it looks like to me. 70% offers a pretty good separation, and you're still getting some of that yellow color in this dye here. So if we look at certain dyes, and again, over those kind of separation factors here, try to zoom in a little bit and highlight it for you. Those dyes do separate into purples and blacks, not soluble in low concentrations, partially soluble in concentrations greater than 20%. If we use this same kind of model here and look at blue dyes, we can see also not very soluble, but completely soluble at higher concentrations. So this is again an example where you'd be wanting to run this experiment at a higher concentration. And then we have green dyes. It's separated into blues and yellows, which might be a little hard to see, but try to kind of highlight some of them here. its concentration of isopropanol is greater than 20%. Yellow solute concentrations of isopropanol less than 1%. So you get kind of this kind of mixture of, depending on exactly what you want to separate, exactly what you're looking for, there will be an ideal concentration to look at and to be able to use for your separation process. Lastly, here we have red dyes. So just looking at the red dye separate into reds and yellows. The yellow is soluble in low concentrations of the isopropanol and less soluble at higher concentration. And not one perfect amount of isopropanol to use. It depends on what color you're looking at investigating and how you want to separate that out. So the red dye is slightly soluble in low concentrations and more soluble at concentrations greater than 20%. So if this is something you want to investigate further, based on these results, that is the concentration of isopropanol that you should be using.